Hello, Math 7 students. This is Utah Middle School Math Project 4.1a. I have modified this quite a bit, so our focus on this is going to be on equivalent ratios, part-to-part, and part-to-whole ratios. This is part of our new unit, which I'm not going to tell you the name of it just yet. We will decide or discover what the name of our new unit is by the end of the lesson. To get started though, we're going to tie in this new unit into something that is old, something that is familiar, something that is pretty comfortable. We're going to start, what is a ratio? Turn and talk with your tables first. What is a ratio? Okay, let's come back together and now please tell me, what is a ratio? Xander. An equivalent relationship between two or more objects? Numbers. So does that mean that it can only be 2 cats to 2 dogs? Okay, so you're not saying that the things we're comparing have to be equivalent, but if I'm making changes to those things that I'm comparing, the changes that I make have to be equivalent. Okay, so instead of focusing on a comparison of 2 equivalent things like 2 cats to 2 dogs, the things could be okay, this is not cooperating. There we go. This could be unequivalent. Nope, it's not erasing. All of this is me trying to erase and it's not erasing. There we go. Okay, it just could be different objects with different quantities. But any changes that I make would need to be equivalent. Ryan, what would you say? More to keep the same proportions. What do you mean by that? Okay, so you're saying that the changes that I make, I'm not making the same changes like subtracting 4 from each one. I need to make changes that are going to keep it proportional. Okay, Gunnar, what would you like to say? Okay, so a common theme that I continue to hear is that a ratio is a comparison. Between 2, I'm going to say quantities. So an example that's already come up is 16 cats to 14 dogs, which we can write as a ratio using a colon, just like we used to see in our lower grades. One of the things that I want you to see is that now that we're in 7th grade, we're going to write our ratios as fractions. When we write them as fractions, it makes it a little bit easier to manipulate them in ways that are familiar and comfortable mathematically. So a comparison between 2 quantities, we can write it like this, but we can also write it using labels. Cats to dogs would be 16 to 14. Now it looks like a fraction. It's not a true fraction, and we'll talk about what that means in a little bit, but we can write it so that it behaves like a fraction, or so that we can manipulate it like a fraction. So here's just an example. Find ratios that are equivalent to the ratio 2 sunflowers to 6 roses. So I've got a lovely little tape diagram here of 2 sunflowers and 6 roses. Write each ratio from the model as a fraction. So you're going to see what we would have written previously would have been something like 2 sunflowers to 6 roses, or substituting the word 2 in for the colon, 2 sunflowers to 6 roses, but we're also going to continue to grow, and now we will be writing it so that it appears like a fraction. 2 sunflowers over 6 roses. 2 sunflowers to 6 roses. Now in this diagram there are some important labels. You're going to notice that part of this whole bouquet that I'm making, part of it includes 2 sunflowers. The other part of it includes 6 roses. But altogether, what is the whole or total amount of flowers that I'm going to have in this bouquet? Caitlin, H. 8 flowers total. So we have, as we're looking at ratios, a lot of these situations that we're going to be described, notice, will be made up of parts, more parts, and can be combined to talk about the whole. Okay, so we're going to talk about that as we progress throughout this unit, or especially this lesson. We can reduce a ratio, which again, this is why we like writing them as fractions, because we're very comfortable with simplifying fractions. And so when we write it like that, it makes sense that we would want to simplify it, or as this says, reduce. We can reduce it to 1 sunflower to 3 roses. Tell me, I know that these are equivalent, but can you tell me what change was made here? What was the change? How did 2 sunflowers go to 1 sunflower? How did 6 roses go to 3 roses? Bethany. Great, and I love the connections you're making to our last unit on scaling. You recognize that we can divide it by 2, or we can manipulate it by multiplying by the fraction 1/2. They mean the same thing, they get us to the same place. How is the 6 changing to a 3? Gunnar. Yeah, exactly. It's the exact same thing that I did up here. So if I'm recognizing that we are dividing by 2, then we're going to divide the bottom part of that ratio by 2. If I recognize that we're multiplying by 1/2, then I'm going to do the exact same thing to the other part of that ratio and multiply by 1/2. Okay. Now that it's simplified, we can also increase the number of flowers in each group as long as we're increasing them at the same rate. That gets us to the idea that Ryan was talking about earlier, that the changes that we make, we want to keep them proportional. We need to change them at the same rate. So how does a 1 change to a 5? Is it okay if I just add 4? What if I add 4 down here? Is that going to get me to where it needs to be? So what is the change, and how should I be looking at the changes? How do I make changes at the same rate? Angelo. Yep. Great, exactly. So we're already, again, we're noticing we simplified this ratio, and now it's 1 sunflower to 3 roses, so I can manipulate that to now increase it by multiplying by 5. 1 sunflower times 5 is 5 sunflowers, and 3 roses times 5 is 15 roses. We can also decide to manipulate this even further. It's not necessarily simplified, but I could decide to simplify it even more by changing it this way. How is this 2 changing to 1/2? Evan. Yeah, dividing it by 4. And so what's happening with the 6? The same exact thing. Any change that I'm making to one part of that ratio, I'm making that same change to all the other parts. So we can also divide it by 4. Now it's not exactly simplified, but it is still equivalent. Yes, Gunnar. Yes, great connection. Again, when we recognize that we are dividing by 4, that is the same as multiplying by its reciprocal, the fraction 1/4. Again, great connections to make to our last unit. Now, list all the ratios we found. They're all listed. Notice that this is a collection of equivalent ratios. Equivalent ratios. That means all of these ratios are equal to each other. I'm going to go in and adjust these. Instead of just having a list with all of these commas, all of these are equal to each other. As we saw through all of these previous examples and the marks that we made, we know how to go from one to the other by making changes like multiplying each part by 5, dividing each part by 4, etc. This unit is all about this. When you have a collection of pairs of values that are equivalent ratios, just what we have here. That is called a proportional relationship. That is exactly what Ryan recognized when we're changing those ratios. We need to change them in a way that is proportional. We need to keep the ratios equivalent. This unit is all about proportions. And throughout this unit, we're going to use the word proportional, which is probably a familiar word, but new in the mathematical term. We understand the concept of proportionality, but what does it actually mean? It means equivalent ratios. So let's also label this. All of these equivalent ratios, this is a proportional relationship. So I have a bunch of ratios that are equal to each other. Temperance, you had a question or a comment? Yes, just like we saw with our scaled copies, when I'm going from one figure to the other, because those sides need to change at the same rate, we were multiplying all parts of that figure by the exact same thing, or dividing, or multiplying by the reciprocal, etc. But we never looked at addition and subtraction relationships, because just like in a scale drawing, it's not going to be changing at the same rate if I'm looking at addition and subtraction relationships. So yes, great concept, and we're going to be getting there throughout this unit, but you're catching on to some really great things, which is we are only going to be looking at multiplication and division relationships with proportions. So that's great. Let's move on then. It says, find two other ratios that are proportional to the ones above. For me, it's on a different slide. For you, it's on a different page, but you know what I'm talking about when I say above, right? So let's review. We had 2 sunflowers, 2, I already forgot, 6 roses. Can you find 2 other ratios that would be equivalent to that, not ones that we have already seen here? With your tables, I want you to manipulate those in some way, shape, or form. And if you finish quickly, answer questions 2 and 3. What if this vase has this many roses and sunflowers? Is it going to be proportional? What if it has this many sunflowers and roses? Will that be proportional? So with your tables, you're going to discuss problems 1, 2, and 3. Pausing the recording as students discuss. Ready, set, go. Okay, coming back together. I'm going to just call on 2 different groups. Each group is going to give me 1 equivalent ratio. So 2 sunflowers to 6 roses. Nisi, tell me what you wrote down. Great, 10 sunflowers and 30 roses. How do I know that they are proportional or equal? Go ahead, Nisi. And what number is it that they are multiplied by? Yeah, they're both multiplied by the same number, and that number is 5. 2 sunflowers times 5 is 10 sunflowers, just like 6 roses times 5 is 30 roses. Notice the relationship here. Notice what symbol I put in between them. I put the equal sign because it is proportional, which means we have equal ratios. So I'm going to show that they are equal or equivalent. Knowing that, I'm going to go ahead and make another equal sign as I call on Jaden. 4 sunflowers. And how many, sorry? 12? Yes, 4 sunflowers and 12 roses. What change did you make? How do you know that they're equivalent? We multiplied both parts by what? By 2. Both parts of that ratio were multiplied by the same number, which is 2. Again, are we seeing some connections to our last unit, scale copies and scale drawings? Okay. A vase holds 6 sunflowers and 18 roses. Is this grouping proportional to the ratio of sunflowers to roses from our original problem? So I'm going to write down the original ratio again. 2 sunflowers to 6 roses. But now as I put this equal sign in here, I'm asking the question, is this equal? Because I'm asking, is it proportional? So I'm asking, is this equal to 6 sunflowers and 18 roses? You tell me. Vivian, tell me why. Yeah, the answer is yes. And what is the relationship? How do I prove it? We're just multiplying each part by 3. 2 times 3 is 6, and 6 times 3 is 18. So let's make sure we're justifying our answer. You know I'm not going to accept just a yes. Yes, this work has created our own argument to justify our answer. You could even add additional words. Yes, multiply both parts by 3. Yes, Bethany? You could divide by 1/3. That is a great that you're already recognizing that relationship as well. Multiplying by 3 is a little bit easier for us to catch mentally. But yeah, dividing by 1/3 is exactly the same thing. Yes, both parts, multiply both parts by 3. So again, let's set up this next problem. 2 sunflowers to 6 roses. And I'm asking the question, is this equal to 9 sunflowers and 21 roses? Discuss with your tables. All right, we're back together. Is this one equivalent? Is it proportional? I haven't yet called on Angelo. Yes, I have, haven't I? That's all right. I already called on you. Go ahead. Great. And I'm especially impressed that you were able to figure out how the 2 changed to a 9. Because it's not obvious. It's not something that we maybe can do quickly in our heads. But if I don't know how to go forwards, what strategy have we already worked on from our last unit? Bethany, what's our strategy? Yeah, work backwards and divide. So 9 divided by 2 would give us that 4.5, which Angelo already figured out. So he's like, well, I know that 2 times 4.5 is 9. What happens when you take 6 and you multiply it by 4.5? Do you get 21? No? What do you get, Xander? 27. So if this was 27, then maybe it would be, but it's not, it's 21. So our justification is, again, it's in our work, but no, the parts of the ratio are multiplied by different numbers. Now, one last thing that I want to look at here. We have already taken the time to simplify this ratio over here. This ratio simplified to 1 sunflower to 3 roses. And so that is what I would like to do. So I'm going to take advantage of the fact that we already simplified that and we got 1 sunflower to 3 roses. So if I get stuck or if I get confused and I'm like, I don't know how a 2 changes to a 9, don't we know how a 2 changes to a 1? Yeah, we already made that change. And now, can you answer this question about a 1 changing to a 9? Yeah. And that might be a little bit easier to do in our head. We don't have to do any of this. I don't know how to go forward, so I'm going to work backwards. Because if we're dealing with the simplified ratio, it helps us see those relationships easier. 1 sunflower multiplied by 9 is 9. 3 roses, when I attempt to multiply that by 9, I again get 27, not the 21 that is there. So you can take advantage of that simplified ratio as well. What questions do you have? All right, I'm going to switch gears just a little bit. Since you guys are professionals now at ratios and equivalent ratios, we need to have a discussion on the different types of ratios that we could have. Part to part and part to whole. To make this visual, take a look at this image. Once again, we had a part of the ratio here represented with the sunflowers, a second part represented with the roses, and the whole amount represented by the total number of sunflowers. So, did I say bouquet, the total bouquet, not the total sunflowers. Thank you for fixing that. So a part-to-part ratio is exactly what it sounds like. We're comparing parts of, I'm just going to say parts. I'm not even going to say parts of what it is. Parts compared to the other parts. So it would be like sunflowers to roses. That's a part-to-part ratio. A part-to-whole ratio is again exactly what it sounds like. It is parts compared to the whole or the total amount. Whole/total amount. So that means for this ratio, we are actually going to have two part-to-whole ratios. One of them is going to be sunflowers compared to the whole or total amount of flowers. But we could also have a ratio of roses to the whole or total amount. What we have focused on so far has been parts to parts. What I want you to do now is, will you please write two separate part-to-whole ratios, one involving the sunflowers and one involving the roses. Do that with your groups. I'm going to pause the recording as students work with their groups. Please write two part-to-whole ratios. Ready, set, go. Okay, let's come back together. Will you please tell me what ratio did you write for sunflowers to total? Daxton? 6. Why did you change it from 6 to 2? Okay, so how many sunflowers are there? 2 sunflowers, but you said in order to figure out this total amount, I needed to go back and figure out how many there are together. A part plus the other part equals the whole. 2 plus 6 is equal to the total amount of flowers in that bouquet, which is 8. So 2 to 8, which we can also write, now that we're in 7th grade, we can write this as a fraction. So 2 to 8. Tell me the roses. What is the ratio for the roses? Sage. 6 to 8. Again, where did that 8 come from? Because we're adding the parts and the parts to get the total amount, which is 8. And as 7th graders, we can also write this as 6 to 8. Now, remember what I said on this previous screen? I say we write them so that they look like fractions. This is not a true fraction. Even if I wrote 2 to 6 without those labels, it's not a true fraction, because a fraction tells us how many pieces out of the whole. But if it's a part-to-part ratio, that's not a true fraction. However, if it is a part-to-whole, these ones, these are true fractions, because we're comparing how many pieces we have to the total number of pieces. These ones are not true fractions, because we're comparing the parts to parts, not the whole. Not a true fraction. Okay. At this point, I don't think that you need a whole lot of extra guidance from me. I still want to include some practice problems done here on the video, but really, truly, I feel like you've mastered those equivalent ratios. Now we're just going to continue manipulating and changing the situation. We will add the step of identifying, after we've done a couple of equivalent ratios, is what we're dealing with a part to part, or is it a part to whole ratio? So I'm going to do number 4 with you, and then I think I'm going to let you work with your tables on the rest of them. Okay. The high school has a new ski club this year. In the club, there are 4 girls and 16 boys. Find the simplest ratio of girls to boys in the ski club. Now, folks, you are famous for just writing down the answers without showing any of your thoughts. So that's why we're doing this together. We are going to model the work that I expect to see on each of these problems, starting with, let's write the original problem. We have 4 girls to 16 boys. So I'm going to write that as the fraction 4 to 16. Notice what I'm doing though. I want us to include labels. So that 4 represented the girls. The 16 represented the boys. So I'm including the labels, and I'm lazy, so I'm including them here at the beginning and just saying, hey, all of this stuff up here is going to represent the girls. All of this stuff down here is going to represent boys. I like doing it that way because the alternative is writing it every single time. And I'm lazy. I've seen your work. I know that you guys are lazy too. So you're going to appreciate this little shortcut of just including that label at the beginning, right? And now it allows us to simplify this ratio. 4 to 16. As I'm doing this, I'm looking for some common factors. What are the common factors between 4 and 16? Bethany. 4 is the common factor. So when I divide out that common factor, oops, I'm going to switch to a different color, I'm sorry. When I divide out that common factor, 4 divided by the common factor of 4, that leaves me with 1. And 16, when I divide out that common factor of 4, 16 divided by 4, that's also going to leave us with 4. So the simplest ratio is 1 to 4, or in other words, 1 girl to 4 boys. This is the work that I need to see. Showing us the original, showing us the end result, and don't forget those labels. So now that we have this simplified ratio, we also have the new ratio, we have some options. When we're asking the next several questions, you can decide, do you want to use the original? Is that going to help you answer the question, or do you want to use the simplified? It's a personal preference. I think in some problems using the simplified version is going to be easiest, but it is up to you. No matter what I do, I'm still going to include my labels, like girls to boys. Let's just take a quick poll so that I can decide who is going to use the original information, 4 to 16. Okay, great. Who wants to use the simplified ratio, 1 to 4? All right, I'm just going to go with majority rules. 1 girl to 4 boys. And the question is now saying, well, what if there's actually 2 girls? How many boys are there going to be? Now we need to start asking those questions. How does a 1 change to a 2? We're doubling that. So what am I going to do to the other part of the ratio? The exact same thing. We're going to double it. And 4 times 2 is 8. So how many boys are there? 8 boys. Okay, your turn. Find another equivalent ratio. Any other equivalent ratio. Find another one. Stand up when you have it. If you're standing, explain what you did with your group. Okay, and now I need one volunteer to tell me what they did. Notice what I did as you guys were discussing. I set this problem up so I could show all of the ones that I've done so far. I have the original, the simplified, the one that we just came up with, and we're going to see one more. Let's hear from Ryan. Say that again. 3 to 12. How did you find 3 to 12? Great. So starting at the simplified one, instead of any other place, we're going to start at the simplified. How does that one change? He decided, let's multiply it by 3. 1 times 3 is 3, just like 4 times 3 is 12. Now, we could go on forever, right? There's infinite possibilities on these equivalent ratios, so let's just stop at 1. And now it's time to answer this question. The ratio of girls to boys in drama club, oh, I'm sorry. That should say ski club. The ratio of girls to boys in ski club is a part to what? Is it a part to part or is it a part to whole ratio? Landon. Yeah, that is a part to part. I'm comparing the different parts of the club versus when I rewrite it in another form. How can I rewrite it in another form? Well, if it's a part to part, then I can rewrite it as a part to whole. Or I could write it as a other part to the whole. We have two options. Which part do you want to use? Do you want to use the girl to the total, or do you want to use the boys to the total? Okay, you decide. Talk at your tables, figure that out, and then we're going to come back together. All right, what did you choose to write, Bethany? You could, but that's just typically not what we would do. That's why it's called part to whole instead of whole to part ratios. Is it wrong? No. Is it standard procedure? No. Does that make sense? Okay. What did you write? Sorry? 4 to 20. So what kind of ratio was that? Like, great. Girls to the total. And if you wrote your ratio of girls to the total, I see where the 4 comes from, but where did the 20 come from? Where did the 20 come from? Temperance. Yeah, adding the boys to the girls, so I have a total number of kids in the club. So the total is 4 plus 16, the different parts combined, which is where the 4 to 20 actually comes from. Is that the only possibility? No, I'm out of space, so I'm going to do it up here. We also could have written the number of boys to the total. We already know what the total is from adding it previously. 4 plus 16 is 20. But this time, if this is the direction I decided to go, then that would be 16 to 20. 16 boys to 20 total people. And again, part to whole ratios are true fractions. So in the drama club, there's 3 girls and 14 boys. Is this ratio of girls to boys in the drama club the same as the ratio of girls to boys in the ski club? You're going to answer that at your tables. Ready, set, go. I have, while you guys were discussing, I've created my labels, created the other equivalent ratios that I already know, like 4 girls to 16 boys, which simplifies to 1 girl to 4 boys, and I'm wondering, is that the same as 3 girls to 14 boys? Again, taking advantage of the fact that we've already simplified it. Do I know how a 4 changes to a 3? No, nor do I really want to try and figure that out. But I know how a 4 changed to a 1. So now I can use that quick fact. How does a 1 change to a 3? We would triple it, multiply it by 3. So if this were equivalent, then I would take the 4 and multiply that by 3, and I would get 12, not 14. So is this an equivalent ratio? The drama to the ski club? No. Okay. The next several problems are just more and more and more practice problems. I really don't think that I need to go over each one. The one that I do want to make sure that we have a chance to talk about is part C. So let's take a look at 5A, B, and C, and then I'm going to let you kind of work on your own here. A cat has given birth to a litter of kittens. There are 3 black cats and 6 striped cats. Number 1, find the simplest ratio of black cats to striped cats. Write 3 equivalent ratios. How do you know they are equivalent? Once you do those, what I ultimately want to talk about is this question. Is the percentage of kittens in the litter that are black, is that a part-to-part or a part-to-whole ratio? So, dive into the problem by working through parts A and B with your tables. Then we can discuss C. I'm going to pause the recording as students work in their groups. Ready, set, go. Okay, we're back ready to discuss C. These are just some examples. The simplest ratio of black cats to striped cats would be 1 to 2. I use that to find some other equivalent ratios. You could have come up with any other versions. It doesn't have to be these ones. But we need to talk about this word, the percentage. Is the percentage of kittens in the litter that are black, is that a part-to-part ratio or is that a part-to-whole ratio? What do you think? I should see more hands. Same students. Let's start with Ryan.
It's a part to whole because it's the percentage of how many total kittens are like black or striped.
Yeah. So if you notice, the percentage of kittens that are black is really comparing the percentage of kittens that are black to the whole entire litter. So whenever we have percentage questions, which we will have a lot in the next coming 2 units, we need to understand that percentages are part to whole ratios. Okay, we are out of time. So your homework is the back page there, 4.1a, the homework section. Do you have to do the other ones that we skipped? No. Is it going to be good practice? Yeah, but all that I am going to be doing for your grade is checking this homework section. That's it for today. Thanks for watching. We'll see you next time.